A little over a year ago, we published our low carbon thermal energy roadmap, which was authored by Global Efficiency Intelligence. And I'm very excited today to have the lead author join us, Dr. Ali Hasanbeigi. Great to have you here, Ali.
Thank you. Thank you for having me.
So before we get into our conversation, I thought I'd just give everyone a bit of a recap of what that roadmap said. So what we tried to do was assess what are the different low carbon thermal technologies that can take us to net zero. And really the conclusion is that electrification is the only net zero viable pathway. And in particular, steam heat pumps are a very efficient and compelling technology to get us there. It garnered a lot of interest and really drew attention to what is the highest emitting part of the sector, which is the thermal emissions in wet processing facilities. So in that past year, AII has focused a lot of this topic and GEI has done a lot of work as well. So what I wanted to do today was bring study into what's possible, into some of the learnings we've had over the past year of really practical on the ground experiences that we've had. I know you've been doing some work with brands and textile manufacturers, so it would be great to hear what are some of the key insights that you've had in the past year.
Yeah, sure. I think the roadmap was quite a turning point for the sector, for the entire sector. Prior to the roadmap, we published one report, which was the first of its kind on electrification of heating and textile industry. And that started, gathering some attention because not many people were talking about electrification of heating when talking about decarbonizing textile industry. And the roadmap kind of took it further, and through the detailed study that we did for the 5 countries, China, India, Indonesia, Vietnam, Bangladesh, we did use a lot of real world numbers from all the work we have been doing, the data we have been getting from suppliers. And that's why I think our results started resonating with folks. And also just putting electrification like in the front and center, and people started seeing it as what it is a real solution for deep decarbonization of the sector, of course, over time. And we are not saying it's easy, we are not saying it's cheap, but it is doable with today's existing technologies. Certain regions might have challenges in terms of procuring the technology, accessing the technology, and etc. But I think the report just did a good job, like as a turning point, kind of shifting the mindsets for maybe not all, but I would say a lot of brands and a lot of suppliers. Again, not everybody, jumping into it and going and implementing it because of all the reasons that we have discussed in the report, the cost and other barriers. But from my work with quite a few brands and their suppliers, they're actively evaluating this and doing the feasibility. I think that is the biggest kind of mindset change that we have seen for a while in the sector. And that's very positive and very, I think, great impact that the roadmap has had.
Yeah, it really has. It's been incredible to see how this has become part of the discourse. And we've started to do some of those assessments ourselves, which we're hoping to result in implementation and given some grants to factories that are piloting the technology as well. And one of the things that we've learned is that for smaller factories, maybe a full electrification is possible. We have one case study that's currently pursuing that. But actually, for the majority of the sites that we're looking at that are larger, it doesn't seem to be possible that you can fully electrify from an economic or technical perspective. Could you explain a bit more about what some of those limitations might be and why pursuing even partial electrification is still very much a worthwhile and compelling exercise?
Brands and suppliers do not, and I emphasize, do not need to go and electrify their entire thermal energy all at once. Absolutely not necessary, especially the large one. It is perfectly fine if you go and implement heat pump or electric boiler and just electrify, let's say, 20-30% of your heat demand. And actually, we recommend people to do that for a variety of reasons. It could lower some of the barriers, like the capital is an issue when you are just electrifying 1/3 of your heat. then of course you have lower capital requirement. Also, when you electrify your heating, you need to connect that electrified electricity load to the grid. And if you are connecting 3 megawatt to the grid versus 1 megawatt, 1 megawatt is easier to connect to the grid. And many other factors. So you could just electrify partially and gain the learning. And also, when you are doing partial electrification, you can target the easiest so-called low-hanging fruit sweet spot when it comes to the medium of heat and temperature. Another factor when we are talking about partial electrification, you can go with the lower temperature and electrify that. And then for the higher temperature, the technology actually is available in certain geographies, like in Europe, in Japan, they are doing heat pump at 170 plus even degrees Celsius, but they're emerging. In 2030, that might be the common technology that's being implemented. So we may not even talk about, that temperature barrier. So when we are talking to actually brands and suppliers, we do recommend hybrid strategy, meaning partial electrification and tie that with their existing systems, and that actually reduces the barriers and reduces the risks.
It's incredible to see that there are case studies in the textile sector, but also in other sectors that have similar temperature ranges, kind of going up to 140, 43, 45 degrees. And as you said, there are emerging cases in the higher temperatures. But of course, the temperature needs in the textile sector can go up to 200 plus degrees with quite a lot of pressure needing to be used. And that's one of the factors where you might say, okay, we cannot put a heat pump on that yet. Could you talk a bit about some of the other factors that you should consider when thinking about the feasibility of a heat pump? We recently scanned a lot of data from some almost 20 factories across India, Vietnam, and China, and there were some key trends that emerged. So it would be really interesting if you could tell everyone about that scanning exercise we did, and if you could pick out the few kind of key indicators that help a factory understand what is going to make a steam heat pump viable for them or not.
When we are screening, as I mentioned, we should look at how the heat is provided and what heat service the factory, different processes demand. And again, in this latest report, we looked at the hot water, the temperature ranges there, and the steam and temperature ranges there. So once we map that out, then we get a better understanding, okay, where truly, for example, hot water heat pump could provide direct heating for maybe some washing and rinsing and things like that. But most cases, it's usually supportive role that they provide hot water heat pumps for preheating of either boiler feed water or the process feed water. And then you see for your different processes, for example, for many of the pre-treatment processes, you have this lower temperature requirement, but you need a steam. And that's the sweet spot you identify. And then for higher temperature, for some of the dyeing, then you might need high temperature steam heat pumps. So through this screening, you can really map things out and see what portion of your plant, supplier's plant, you can electrify and then go with the hybrid strategy that I mentioned. But also you need to look at, depending on where your plants are located, how your electrical systems are and how you're going to connect this electricity to the grid. Because we are talking about significant load added. We are talking about heating that is electrified. So if you are not able to add, additional load to the grid, then that could be a significant challenge. So you need to, from beginning, think about that.
You laid it out very clearly, mapping the different processes that a factory has, the temperatures that it's using, whether it's dry or steam. I think that lays it out really clearly. And the transformer capacity we know is incredibly important to know about, not only because, you might have a maximum. We've seen in some cases that a factory simply cannot add because of the regional constraints. But even in cases where they can, it can often be quite expensive and maybe make the project uneconomical. But I'd also love it if you could touch a bit on the spark gap, so the ratio between the electricity that a factory would now need to purchase to power a heat pump versus the cost of fuel that they're currently having, or cost of steam if they're purchasing that central.
A steam heat pump usually give you a COP, coefficient of performance, of between 2 to 3, often around 2.5, even can go to 3, depending on the integration and heat recovery. So we are talking in a simple form, 200% to 300% efficiency. So you can see it significantly reduces your energy consumption, heat pumps, compared to the conventional boiler, which has only efficiency of, let's say, 70 to 80%. In all the analysis we have done, heat pump often has lower energy cost, just energy cost per unit of production, compared to the conventional boiler. In almost all, I don't remember any case that was not the case, because of this massive efficiency gains that they give us. But the problem of heat pump is the capex is significantly higher. We are talking about 3-4 times, sometimes higher, compared to the conventional boiler. So there you need to look at what we say is a lifetime cost of the technology. What we do usually, we calculate the levelized cost, where over the 20-25 years lifetime of the technology, we include the capex, opex, energy costs, and if you have carbon costs, and then for calculate it for coal boiler, for natural gas boiler, for heat pump and electric boiler. And in all the analysis we have done, heat pump always have the lowest levelized cost, dollar per unit of energy, thermal energy that it produces, sometimes by far. So when you install the heat pump, to wrap up, your payback might be 5 years, 6 years, 7 years, not 2-3 years. But then after that payback point, you are saving literally millions of dollars over the lifetime of the technology. So that's something to keep in mind, that for these transformative technologies, you cannot really run them by the payback period of 2 to 3 years that are usually for the retrofit and like a smaller kind of projects that plants they do. I hope I answered the question.
Definitely. And I think to maybe summarize, the lower the electricity cost, that 5, 6, 7, 8 years might be a little bit closer to 2 to 3 years, which is what textile manufacturers are typically looking for. But regardless, the levelized cost of heat over time will be better. And I think that's a tension that we have in the sector, is that investments have to be made in this very short-term horizon. But of course, an energy asset, it has a much longer duration than that. And that's definitely a financial tension we experience. And what we've been thinking a lot about as well, which I would love to hear your input on, is, well, we have high temperatures, we use a lot of steam, the electricity fuel price ratio really fits into that. But to make these systems more efficient and more widely deployed, we can also reduce the amount of steam, lower the temperatures of what we're doing. And there's optimization that we can do within the factory, or innovations on the way we do things. So I'd like to hear from you where you think that type of work sits in, maybe in preparation for installing a heat pump, if we're thinking from the journey that a textile manufacturer might take.
Absolutely. Very good point, a very important point, because if you require lower temperature for the heating, that makes your electrification easier. So always, yes, start from system optimization and see if you can reduce your heat demand, reduce your temperature of the heat that you need, and then go talk about the electrification. And it makes your life much easier if you need lower heat demand and lower temperature.
Yeah. And I think it's important to point out as well that when you're sizing a heat pump, because it's not a buy off-the-shelf technology, you're really sizing it to the system that it's delivering heat to. It has to be sized to map your processes. It cannot, those calculations have to be really accurate. So any work that you can do to optimize the heat that you need means that the system can be sized to more efficient steam delivery, which will always improve the economics of the project.
Yeah,
so
significantly reduce the capital cost. We are talking about hundreds of thousands of dollars.
Yeah, definitely. So if we think a year from now, we've made a lot of progress already. We're doing pilots, but what would you really like to see to happen in the next year? If there's one thing you could wish for that you think is really going to move the needle so that maybe we can exit pilot stage and move into demonstration, what would that be?
I think at this point, I truly believe people know this technology exists, it's commercial, and it is working, but they're hesitant. We are in this sector, textile and apparel, we are in the phase of first movers.
Yes.
And lighthouse project. And for many, it's going to be the case of seeing is believing. So I would like to see more first movers. I do hope we see a couple of more in the next 1 or 2 years. Steam heat pumps implemented and operating. And I do think once we have a few of these operating in the sector, it significantly reduced the perceived risk. And then you will see people come and invest because it is a technology that works and it's been around for a while. It just in this sector has not been adopted. And I do think, because I just talked to technology providers in India and in China, as they adopt more of these, they're going to lower the cost as well, which significantly help heat pump, because heat pump barrier is the capex. As they install more, it's going to lower the capex. And the economy of scale does not happen with time. It happens with adoption, with installation. So I do hope we see more industrial demonstration pilots happen in the next year or two. And hopefully in 2030s, we are going to see more of a mass adoption in the sector.
Yeah, that's great. And luckily, that's what we're really focusing on, is to support those first movers and to publish the learnings from that and organize site visits for textile manufacturers to visit each other where we can. Because I think, it's not an inconsequential thing, right? It's a new technology for our sector. Mm-hmm. And if it doesn't work, you don't have any energy to power your production. So you need to believe that it's going to work and not have any interruptions for your core business. So we really understand that risk, and we're very much looking forward to sharing the learnings from those projects we have ongoing. So yeah, thank you so much for your time today. It's been great to catch up, and looking forward to see what great learnings and increased projects we have in the next year.
Great. Yeah, thank you. Thank you for all the work AII is doing and yourself. I think AII has become a center for really pushing and supporting this transition. I would say transformation, really a significant transformation in the sector. I work across different sectors, and most sectors I don't see have such a center like AII to support this transformation. So thank you for all the work you guys are doing. And yeah, looking forward to continue collaborating with you.
Thank you. That's really nice to hear.
Thank you.